Hey guys, welcome to another video on linear algebra using Python and a symbolic package called SymPy. So what I'm sort of doing is importing the package. So from then SymPy import. Okay, then I'll type in this initial printing. Then use Unicode. And then pretty print. Okay, and then I've got a matrix. I'm gonna call it matrix M. So I'm just gonna find out its determinant, inverse, eigenvalues, and eigenvectors, and then so forth. So what I'm sort of doing is assigning a variable M to the matrix. So M equals matrix. It could be a 3 by 3 matrix. Okay, so that'll be 2, 1, 1. So 3. Okay, so that's my matrix M. Okay, so I want to find its determinant. So that's M dot minus 4. So the inverse exists because the determinant is not 0. So in dot n. Okay, so that's our inverse there. And then I need to find the eigenvalues for this matrix. So M. Okay, and the characteristic polynomial. So sorry. So you will use lambda as default. So lambda cubed minus 4 lambda squared minus lambda plus 4. So that's a characteristic polynomial. And then obviously the eigenvalues are usually are the roots of this polynomial equation. Okay, so then I need to find its eigenvectors. So here are eigenvectors, and these are the roots of the polynomial. So minus 1, and then 1, and then 4. Okay, so minus 1, 1, and 4. Those are the roots of this polynomial. Okay, so then I'm going to work on LU decomposition. So M dot okay, so that's lower triangular, and then this is the upper triangular matrix. So lower and upper triangular. Multiply these two, you get back matrix M. Okay, and then I need to find I need to do the row reduction as well into row reduced echelon form. So M dot. So you get the identity matrix. Okay, and then if you want to find out if a matrix is, you can diagonalize a matrix. You can type in this code. So M. So that's true. So we'll proceed to do that. So I'll call it then P. Yeah. Dot diagonalize. Right. So matrix P, so on, and then matrix D. So that's the diagonal. So that's the roots again. The roots for that characteristic polynomial, and those are the eigenvalues as well. Okay, so I need to show you a neat little trick. So so is D equal to the P dot inverse times matrix M times P. That's true. So all I've done is, so if you multiply the inverse of P times the matrix M again, and then times P itself, then you'd get D. So basically like saying, let me put it this way. Looks like pimp, you know. Yeah. So that's diagonalizing the matrix. So you'd get the eigenvalues of that matrix. Okay. So now I want to do the trace of the matrix. Oh no, the transpose. Sorry. So okay, that's the transpose of that matrix, and then I need to do the trace. That's 4. So that's the sum of the diagonal. So 2 plus 2 is 4. So yeah, so hopefully this is a quick tutorial and a helpful video. So if you got any comments, just hit me up at the bottom. And on a final note, have a good day. Keep smiling. So thanks guys, have a good day.